So over to you, Alistair.
Okay, thank you. Okay, so welcome to everyone to this webinar on trustworthy software and system standards. I'm doing the introductions and welcome this afternoon. My name is Alistair Ravel. I'm the Director General at the Institution of Analysts and Programmers, and I'm also chair of the Trustworthy Software Foundation. In terms of the sort of housekeeping and bits and pieces, I'm joined by the president of the Institution of Analysts and Programmers, Graham Fenton, who is going to sort of chair the sort of Q&A at the end. We both happen to be directors of the foundation, but the meat of this webinar is about trustworthy software and system standards, and I'm delighted to welcome John Ellis and Luke Polin to make this presentation. But before we proceed with the presentation, let me just briefly introduce them. John is a fellow and companion of the Institution of Analysts and Programmers. He's got nearly 50 years of software and hardware development experience. During his time as operations director for the IAP, he also was part of the Cybersecurity Alliance, which created the UK Cybersecurity Council. He also provided technical support and development of custom websites for individuals and small companies across the southeast of England. In the last year, he has moved from England to Wales and taken this time to refocus his main business interests. The focus now is on IT security, standards and solutions, working in the main with small and micro businesses still. He is currently chair of BSI IST 33.4 working group on security controls and Services Committee, which deals with cybersecurity, and is a long-time member of the BSI and ISO committees on trustworthy software. He is currently working on a project alongside DISA and others to provide a register of suppliers for the Ministry of Defence, aligning some IT-related products to recognised standards. So that's John. Moving to Luke. Dr. Polin is CEO, Research Project Director and Strategic Advisor in Cybersecurity and Application Security at the Application Security Institute, Cogentas Inc. He has extensive academic qualifications, including a doctorate in software engineering and over 40 years of experience in IT systems and software engineering. His expertise in cybersecurity, he specializes in integrating security into the application lifecycle and has contributed to various research projects in information security, including e-voting and blockchain. And in terms of the sort of standard council or standards council involvement, he's been actively involved in multiple standard councils since 2006, focusing on software trustworthiness and cybersecurity standards, notably leading the ISO IEC 27034 project on application security. So welcome to you both. I'm looking forward to this presentation, as I think everyone who is with us is indeed. So I'm going to hand over to you both to take us through your presentation. Thank you.
Thank you, Alistair.
Thank
if I
you
kick
very much.
off you go.
Yes, go, yeah, John.
Okay, just a quick run through of the agenda. Thank you for the introduction, Alistair. We'll cover why standards matter, what is trustworthy software, which is a minefield in its sense, some of the key standards and initiatives that are currently in progress, a bit more of the detail of that progress, some of the challenges and conflicts that we come across with standards, and then what the future will hold. And then we have a Q&A at the end where we, unlike normal Q&As, we actually have some questions for you as well.
So it will be very friendly presentation. So feel free to interrupt us or ask any question on the fly. We will do the same. We will interact together, me and John, and you're welcome to participate anytime.
Off you go, Luke.
Okay, so why standard matters? Okay, roughly at the beginning, what is a standard? Standard is a summary of best practices that were gathering by consensus from an external expert. So usually we got consistency because everything is challenged. It can address safety or not sure for this one, and interoperability. Okay, go with your example because it's your example, John.
Okay, so if I go with the first one, when I first got into standards, it was ISO 9000, and the book on it, bizarrely, the opening paragraph was about the Napoleonic Wars, where we were fighting the French, and apparently British cannons were built to one size, and so were the cannonballs, whereas the French were a little bit more ad hoc. Consequently, if you destroyed a British cannon, the cannonballs could be moved across, whereas the French, that was it, those cannonballs were out of action. Taking it back to you there, Luke, if you want to do the cross-domain software reuse.
No, continue in that part.
Oh no, I'm trying to remember what we said about this one. Okay, so with software is making sure that the software that we're using is consistent, whether it's on whatever domain environments, and making sure that those components are safely reusable without, and we'll come back to it later, but all equally secure. Luke.
Yeah, but so we will talk about the safely part. But let's say cybersecurity address the integrity, availability, and confidentiality of information, but also the infrastructure. Okay, so when we got best practices together and they are agreed, so that means it will help to reduce the risk because these best practices are related to elements or risk that we have on software development or system development. It will also minimize uncertainty because we cover what was or what is generally accepted by the expert all around the world. The best practices, we already talked about that. Provide shared expectation and terminology. The second trap we are having in engineering, software engineering and system engineering is not everyone use the same term for the same definition. And the concept of software and application is one of them. The concept of trustworthiness too is in the way to be shaped. But let's say we still have a lot of discussion. John and I, we are working on working group 13, another ISO committee, and we're still struggling to make sure what exactly is trustworthiness, what exactly is trustworthy, and what exactly is trust. On the human side, it's quite simple, but in IT side, it looks like it's become more complicated. By having consensus on standard and best practices, that generate a common vision. And because it's mostly process, that means the expectation, the result of each process is done, terminology will also. So roughly, cybersecurity address 3 key risks: availability, confidentiality, and integrity. Privacy is not part of cybersecurity officially, but let's say usually it's always attached with them. Other characteristic will come with trustworthiness. Safety is one of them. Robustness, reliability, explainability, demonstrability. So we will have more characteristic that will be added. We can say cybersecurity 2.0, but the term that is coming by the industry or by the standardization world will be trustworthiness. And if you all characteristic or address, the system or the software will be trustworthy. So what is a trustworthy software? So it's a software who will satisfy the requirement. Okay, so cyber secure is for cyber security. Reliable, resilient, safe, recoverable, resistant. So we are now around 80 characteristics that can be selected and important for a system. So how it will be addressed? Roughly, we will define a risk management approach that will consider all these characteristics on high level, and every characteristic that can generate an unacceptable risk will be part of the characteristic to consider for the system. So the standard will include the governance, how to manage these practices. It will focus on the complete software lifecycle, or let's say system lifecycle. They are also defined by ISO. The software is ISO 12207, and for the system is ISO 15288. If you compare these two standards, they are very, very, very close. Some experts ask why we're having two. And build confidence about user and regulator. So, and it could be the subject of another standard. The challenge will be today for each characteristic, let's say integrity. So if I want to talk integrity on a storage, I may decide to implement cryptography for the confidentiality and put some other controls to ensure integrity of my information. The trustworthiness will be, how do you verify that it's work? And can you collect evidence of your test? And this is how slowly we will develop trustworthiness. That means we cover everything, but we can able to demonstrate that the risk was correctly mitigated and the control work as expected. So that will be the coming challenge. And it may change a lot inside the way we do cybersecurity. Um, and it could be a part of another discussion. Something to add, John?
No, you've said it all.
Okay, so key priority for an organization. So when we will start, we just talk about that before the presentation start. He said organization are looking for. No, I just read that on LinkedIn. People do threat modeling at the beginning, and after that they forget, or they will do every 2 years. Okay, so the first part is we have to understand where the system or the software will be used. Okay. For now, as all start are in discussion, it's not written on stone, but that give an idea. We have to identify 5 contexts. The business context. If your software is developed for healthcare or for transportation or for support a nuclear power plant, the risk coming from the business context are different. And maybe a software designed for one business context and considered secure on that context will not be secure in another one. Regulatory context. If you develop a software for UK and you want to sell it in US, Canada, or in China, where I am now, regulations are different. And even if your system or software comply with UK regulation, it may not comply with the regulation of the country. So that will have to be considered. Technological context, this one is simple. If you have Wi-Fi, not Wi-Fi, fiber, depending of the network, depending of the CPU or any hardware you will have, technological element, each of these elements have their own risk. Hard drive may crash or fail itself. So this risk have to be considered. Ecological is new. It's coming with the trustworthiness part and with the safety part. And we extend the safety not only on human or person, but we can extend it to pets, animal, even ecological system. So the context may ask you, we may have risk that a system or a device have an impact on the ecology and have to be considered. The last one come from AI, the societal and ethical context, how an AI can provide fair results, how an AI can act on an ethical manner. that will be challenging to define. And my gut feeling is societal and ethical will be attached to the society. So that means something that we consider ethic in UK may be not be considered ethic in other country or another religion. And that means maybe the software engineer or at least the team may have to start to consider that other people may have other viewpoint than us, and the system will have to be adaptable for them. So this is the context where the system will run what we call the environment, where it will be used. We may have more political or some others can exist. Now, where are the source of the risk? The other source of the risk, the system, the purpose of the system have to be clearly defined. Okay, the example I'm using is a car. So everyone know the BMW Smart, it was calling Smart Mini before. Okay, it is an urban car, and that car can be secure running in London. Okay, but if I decide to go camping, because I'm a camping fan, and I want to pin a 15 feet trailer behind my Smart Mini, maybe, and I decide to go in a mountain, maybe I'm not secure or I'm not safe anymore. So when you use a system or software outside its context of use, you may have problem. So the system function, specification, information items that you will manipulate, communicate, store, all these elements may be source of risk and have to be considered. And the risk will be considered from the system characteristic that you want to address. Cybersecurity, say privacy, safety, explainability, etc. That will be all attached to trustworthiness that is coming. Do you have any question? Does that make sense for you? So the standard was, yep.
Sorry, Luke.
Good.
I was going to add is that if you look at this and then think slightly outside the box, as we have done with the car, is that what we've identified is that within the standards, actually a lot of this applies to almost non-IT systems. So the car is a good example, a bus, other hardware, and that's something that even within the standards that we're working on, although we're focusing on software, cyber, AI, is that a lot of these characteristics, a lot of these specifications have wider impact. Shall I cover this bit, Luke?
Yes, my pleasure. Go.
Okay, so if we talk about trustworthy software, many moons ago, 2014, this was published and it had been worked on for quite a few years beforehand. Another fellow at the institution, Ian Bryant, was highly involved with this. And this was the beginning of the UK's thoughts on trustworthy software. It's a publicly available specification. The license is actually from the Ministry of Defence, but you'll find the papers are under the BSI. And it started to introduce the definitions, the characteristics of what trustworthy software is. And as it says here, we've covered the development, the operation and maintenance of systems, and that has become the foundation for later standards. What's interesting here is although this standard has now been moved on to a British standard, it is still being looked at and managed by the, I'll get this right because I always go council, but it's Advisory Committee on Trustworthy Software, and it's still being updated with a view to pushing the standards and ideas here forward into the next generation of standards that will be coming down the track. And this was launched at if I remember rightly, Alistair, because you were there, it was launched at a quite nice venue in Westminster back in 2014, and it seems such a long time ago, and has progressed quite a long way since.
Yeah, I think it was the conference centre in Westminster, wasn't it? Which was a great venue with a government minister present, making the presentation.
It certainly was. I can't remember the minister's name, but I'm sure he's not in power anymore. So this led to the British standards 10754, and this was based initially on PAS 754, which was 36 pages. As you can see down the bottom, it expands within the standard to 44, which, to be honest, is quite relaxed. And it does cover the whole idea of governance, making sure that software is, from the companies that are supplying it, do they have procedures for not just creating the software, but ensuring that simple things like, is there a manual? Has the software been tested correctly? Has the software company in part been validated to a certain extent that they have proper procedures? And although when this document was created, cybersecurity was still, I'm not going to say in its infancy, but certainly was not as prevalent as it is today. And consequently to that, 10754 is starting to encompass that at more of an international standard level. So this took 4 years before it was published, which, to be honest, is very quick, because Luke and I will tell you that some ISO standards, we've been working on some of this for over 6 years. BS 10754, I put here, has continued to be worked on. There is currently BS 10754 0, 2, and 3. But at the current time, they've literally in the last couple of days been paused. I'd dread to use the word cancelled, because give it a couple of years and they'll come back. Usually a standard is only published if there's a business need for it. And consequently, at the moment, they don't see a business need for the parts. And this would expand quite significantly on the work we've done here, incorporate the work being done by ACS, and look at other technologies that are coming down the line. Back to you, Luke.
Okay, so because trustworthiness was emerging and everyone have his own definition, GDC1 decided to create the working group 13 on trustworthiness. The objective of this working group was to try to define clearly the definition, the concept of what is trustworthiness, and after that, push other ISO standard or ISO committee, what they call SCs, to be aligned. If someone develop a trustworthiness standard, he have to reuse the concept and the definition provided by Working Group 13 on the way that all standard will address trustworthiness in a similar way, with the similar vocabulary and the similar concept. So this working group exists for, let's say, nearly 10 years now. 8 to 10, I'm not quite sure. I mean, they're there for nearly the beginning. And it will look for the software, but it's more an approach to entity. That means that the entity can be an organization, a system, a software, an application, or services. Okay, an example, electronic voting system could also be seen as an electronic voting services provided by the government or an entity. for someone. So it's just the way that we define the scope and the perimeter of the system that will be under the scrutiny of trustworthiness. People are like all ISO committee, you have people on many countries that will work on there, and it's a work in progress. We are looking to publish the first document. Vocabulary is already out, but if other let's say some people don't agree, it's a version 1.0, and we will have a version 1.0 of overview and concept that will be published if it's going well this year or next year, let's say 2026, and we will see. So trustworthiness, as I said, is cross-domain. That means the system, whatever is an AI, an IoT, or cyber system, have to be trustworthy. And the challenge will be not all systems need the same level of security or the same level of trustworthiness. How do you define that? And how do you measure objectively that this level of trustworthiness was achieved? So this is the key discussion that we are today on the writing of this standard. And yeah, because the concept is new, many experts agree and disagree, and good discussion are going on, and we will see what will be produced. It's always the same objective: define a consensus on the best practices. And here we are in the beginning. That means definition of concept and what we are talking about exactly. So 31303 is the first document that is coming, overview and concept. So he will put the table on what mean trustworthiness, what mean trustworthy, what mean trust. We are going to see if we will include trust or not inside the scope. It will define the high-level characteristic and expectation of each one. Okay, a system must be robust. What that mean exactly? A system must be reliable. System, and is not always the case. So the characteristic will not be. Maybe we will have a baseline, but they will depend of the type of the system or software and the context of view that will be done. If I develop a router for family, or if I develop a router for a telecom company, if my router crash in my home and I'm watching Netflix, I will say, zut, I will get up, put my beer on the side, walk in the room when the router is, reset the router, go by on my couch and continue the movie. So my uh, unacceptable risk will, or my risk will be to lose 5 minutes. If the same router crash on a telecom company, millions of customers will lose their connection, and maybe some connection was critical because an hospital was using that to make a live streaming on vital sign of someone, and maybe someone will die. So the same device, depending on the context of use, will have different risk. Trustworthiness must be able to be flexible enough to address both and consider both trustworthy in their context of use. So as you see, many elements have to be defined. And at the end, the objective is regulator or user will be able to validate that it's the case. And of course, language and cultural alignment challenge is just here anecdote. Trustworthiness, this term do not exist in French and in Japanese. We are having the term trust, but not the term trustworthiness. So we already have some discussion to say how it can be explained, this concept, on country where the language didn't have the term.
Yeah. But I was going to say, add to that, Luke, you and I both have been at these meetings where a 3-hour meeting has been devoted purely to trying to define what those words mean. And yep, each country has a different view. And in some cases, countries that you think where the English language is prevalent and the words should mean the same, they don't.
Yeah, and even between English people speaking people, sometimes they don't have the same definition for the same term. So that's quite funny. Next slide, maybe.
Yeah, we're on it.
Okay, so yes, thank you. 31 303, we are in CD2 since last week, 2 weeks ago, sorry, 3 weeks ago, beginning of the month. And we try to, so it's still a work in progress. We had a convergence with UK and international standards. So UK is highly active. Me and John and also Andrew Banks is working with us to try to help. All contributions are welcome. Um, and we try to produce that this is for the next year. If everyone want to be involved, talk to John. He is the head of delegation and the chair for this. No, you are for the ICC 33-4. So talk to John in a way, and we'll try to make you involved if you're interested to participate, or if you have some idea how we can manage that. All viewpoint are welcome.
I think we've covered some of the terminology, haven't we?
I already thought about that. The first bullet. Ontology standard exists, but underused. Let's say we are developing an ontology standard also for trustworthiness. In my personal viewpoint, we are too early because the model is not defined, and I don't see how we can define an ontology without the model. But some other experts are not in my opinion, and they're already working on it. So we will see what will happen. Let's say the key concept is to define concept that will be used to be harmonized by the other SC's committees. Here you having three: SC27 for cybersecurity, SC41 for IoT, and SC7 for everything software and system engineering. And committee must negotiate more boundaries. For now, it's not done yet because working group 13 didn't produce nothing really.
I was going to say, I'll add on this, Luke, because one of the things you'll find with, particularly with ISO, is they are very good at characters that for words. So JTC, which is Joint Technical Committee, which is ISO IEC. I'm trying to remember what CD is. It's a something document, isn't it?
CD is committee draft.
Committee draft. There are lots and lots of shortened words, and even now I still come across them and go, "Oh, what's this?" And we'll cover some of those in a minute.
Okay, so politics behind standard development. Okay, it is a standard development is a consensus. Theoretically, is the expert who bring their viewpoint, but it's not always the case. It will be always also expert work for company that may have a strong vision on what it should be. You may have conflict between these experts, and you may also have conflict at the national level. So you may have country that want to go in one direction and another country want to go in another direction. So I didn't expect that when I start working in ISO, but I discover over the time that it's not only expert, it's also political. Maybe less political than ITUT, but still political. So it requires diplomacy and patience. Let's say respect is the key word that we should have or shall have during our meeting. And the challenge is to try to have a consensus on all decision that will be put on a document. And consensus didn't mean unanimity. It means majority plus some. So that's highly subjective and it's a work in progress. But roughly, when everyone is in good faith, we succeed to collect the best practices and agreed on what we should put inside the standards. Okay, so the feature of standard development, okay, we want to have reliable and ethical software. Okay, so I challenge you, define me what is ethical software. Okay, we are not there yet, but it will be something like the system, and it will be closed with AI. Okay, the system will take decision because AI is nearly a digital person that is embedded in the system, will take decisions that are ethical. Okay, and we have to define what that means. Okay, we have a stronger links between safety, security, privacy, and trust. Okay, but the trust will be roughly if all the characteristics we decide that are important for a specific software or a specific system are addressed, and if we receive all the required evidence that these characteristics are mitigated on the right level, we may decide to trust that system. Go back with the car example, okay? Did a car is safe? No. Millions of people die in a car crash every year. Do you will put your kids, or did I will put my kids in my car? Yes, because the car is safe enough, and the unacceptable risk that we got a car crash and everyone die is acceptable. The residual risk that we have today is acceptable with the baby chair on the car, the belt, the airbag everywhere. So it's a bunch of control that are tested, that are validated, and we know that they will work. So the risk is mitigated enough to make me trust that it's safe to put my kid and myself on my car. Okay, and that will be something like that we'll have to where we will go. Okay, developer engagement with standard will increase because standard are best practices, and because these best practices are well recognized around the world, because it's provided by experts from everywhere. That will start, I hope it will start to become some kind of foundation on best practices to implement if we want to implement cybersecurity or trustworthiness inside the software or the system. We may have a meeting one day or a discussion. What is the difference between software and application or system? Where one stop and the other start. Um, Participating to develop standard, you have the opportunity to shape the future framework. That means you can bring your ideas, because I'm sure all of you are more than a lot of years of experience. You saw what good system and bad system, or good software, bad software are, and you may bring your viewpoint about what should be important to be written inside the standard. And of course, emerging technology are always a new challenge. Did the standard is generic enough to address them, or do we need to update the standard or expand the scope? AI is a good example. The actual standard are not enough. The AI will change a lot on the way that we integrate. An AI component usually will go inside an existing system. If we talk about cybersecurity, you may have a system to monitor your network and detect intrusion or detect any event. You can plug an AI on that. So what will become the system? This is, and how do you define that this security system is secure by itself, and it don't collect private information or privacy information? That will be a lot of elements that have to be adjusted and improve on the existing standard that we are having now. So if you want to go in the team that are writing and fighting to put the best practices there, you're welcome.
Just to add to this is that for reliable software, which as Luke said, if it's your router that's broken, fine, and can be reset. But in an example of reliable software is it's not just the fact that it does what you've asked it to do. So if you've got a routine, all it does is works out the VAT, a nice simple value added tax, and you've tested it and you've proved it does it. But what you do, if you've published that VAT is calculated on a figure from 0 to, let's say, £100,000, and that is what you've said your software is going to do. If someone puts £100,001 in and it fails, as long as you've published you are reliable to that state. And something that some of our colleagues, I think, have an issue with on occasion is that if you can prove your software through retesting and keep testing, so you can validate each time that your software is doing what it says it does on the tin, it is reliable. And in terms of ethical software, which obviously includes safety, security, privacy, and trust, another element of that, and Luke may slightly disagree with me here, but I don't think so, is that if your software says it does X, but there's a Y somewhere that somebody's added a back door and another function that shouldn't be there, obviously that is unethical, because this is where the software could be phoning home and sending your data back to somewhere that you shouldn't have. So having the ethical and software really does cover all this safety, security, into the links between this and cyber, and this and IoT, and this and any other technology that comes along. It is quite important.
Go, John. Continue.
Oh no, I've talked too much. There you go. Okay, so some people think standards are blockers. They're not. They make the software safer. They make the software accessible, standard, so that people are, if you've said you've used that standard, people will trust your software. If you get a chance, as Luke said, get involved with the standard. There are lots of standards, or within a standard, there are lots of working groups. So working group 13, which is Trustworthy Software. There are other working groups on IoT, on AI. There was one that came up only a couple of weeks ago that was a proposed working group on pilotless aircraft, UAVs, and it was all about cybersecurity. As it was, this one was shot down is probably the wrong word, in that although it was there for cybersecurity, there was a nice diagram at the time. One of the attacks was actually to put something that upset the GPS signal, which is outside of cybersecurity. And another one was actually somebody walking into the control center for the UAV and altering the programming internally. So there was a cyber attack, but literally from what was quite a big proposal, it literally came down to one, so it was refused. But there are many other working groups that are available, not just at ISO level, but at British standards as well. You can obviously subscribe to updates with BSI and ISO, and they have groups that you can follow. and trustworthy software systems with thoughtful development. We always have this discussion, as Luke said, whether it's a system, whether it's a software, whether it's an application, and there's a whole discussion that goes on around that. But it is important to think about, so it's like security by design, and what standards do is just add to that. So as you're designing your software, it will be underlined by the standards we're creating. Everyone should be aware of the standards related to cybersecurity and privacy. It's a bit like ISO 9000. Lots of companies use that. And then now this should start to trickle down and be used and be enabling, not just for big companies, but for smaller individuals. Identify and implement the appropriate standards related to your requirements and indeed your customers' requirements. Part of the work that I'm doing at the moment with ADISA is that we are actually looking at taking standards for a product here with standards for a product from maybe America and seeing where they actually meet, so that we can make sure that they have equal standing or not equal standing on our register. And this is because the end user, the end client, wants to know that that is reaching a certain level. Certification and compliance, there are national accreditation and international recognition of standards. With ISO, it goes through quite a long, drawn-out process. Some standards go through very quickly, but others, well, we've been working on Working Group 13 on and off for 10 years, and I suspect it will go on for another 2 or 3. But we are getting there, and there are stages where the experts are saying this is what should be in it. It then goes to other groups, other working groups who might be involved, who will look at it and go, oh, I don't agree with that. And they will send their comments back and it will get revised. And then we get to a point where it's sort of ready for a final review, and it goes out. Nobody's allowed to technically alter it. It's usually if someone's put a grammatical mistake, or if it doesn't agree with ISO standards, and ISO in their own right have standards on standards. And then we get to a point where it becomes a draft release, and shortly after becomes an ISO standard. And BSI work in a similar way. They tend to mirror each other in terms of committees. I can't remember what we meant by that, but implementation in a way to it. Oh, sorry. Yes. So it's when we do implement these things, they're not designed to be punitive, but they are there to assist in validating and making sure you are complying with the standards. And then again, go on, Luke. Yeah, sorry. Partition.
Go. Sorry.
And then participation in standards development. It is useful because you go to these meetings and you learn as well. You get other people's views, and sometimes you go, oh, I hadn't thought of that. And that is quite useful, particularly with BSI. Obviously, you're dealing with people in the UK, but in ISO, you're dealing with Australians, you're dealing with Chinese, you're dealing with Americans, and they all have different views, different thoughts. And sometimes it's quite hard to think, oh, I disagree with that, but you learn about each other as well. So we certainly would recommend you getting together with people doing standards, and it will help. It helps you and it helps the industry. So yeah.
And if your organization, for the last line, if your organization thinks that no standard fit with their needs, by participating in a standard development, you can bring these needs inside the standard team and make sure that the standard team will consider these needs inside the standard. So they have two win to participate in the standard. First, you got an early vision of where the standard is going, and you can influence what is going. And second is you can make sure that the needs of your organization, your developer, or your business will be considered in the standard because you will bring the best practices or the requirement related to these needs. So you will make sure that the standard address your business also.
Brilliant. So this sort of brings us to the end of the presentation, but we actually, ahead of yourselves, have some questions. So I think, Graham, if you want to sort of maybe handle the Q&A from the attendees, and we can try and drop these in as we go, or we might get people actually asking them.
Okay, well, thank you, John and Luke, for such a riveting talk. It was very interesting and sort of, it sounds very, very, very complex, but we'll start the analysis. What are your vision for trustworthiness, standards in your organization, industry, and or country? Question mark.
Yeah.
Who to start off?
So that's well, this is us asking the people attending if they are doing anything about standards, but if they've got a question, we're happy to take that as well.
The first question is, did you aware of trustworthiness?
Yeah.
So Joe, would you like to speak? You're on mute at the moment.
Sorry, I was going to begin to type it as well. I don't know if you can see me. Sorry. Does my camera come on?
It has now.
There you go, and you can see. I'm doing some consulting in the utility sector at the moment. We're making a lot of reference to 62443 and safe by design. I think 62443 section 3, without looking up, is about system development and a secure development life cycle. You guys will be aware of that sort of thing, yeah? And I guess what you're working on references or plugs in and dovetails with that?
In part, I would say there are a lot of standards, and sometimes you do have to go away and find standards that are similar. And what has happened over the years is that some standards were there, and then some of the standards maybe down the line will either be rolled into what we're doing. And I think I'm right here, Luke, if in the longer term, they do try to maybe update, roll into and remove the older standard, or the standard will get redeveloped at a newer release. But there sometimes are overlaps because of industry, and sometimes overlaps because there isn't the time to go back and alter another standard, and it takes time.
Yeah, they overlap also because every subcommittee works in silo and they don't talk everyone together. But you see, Joe, when you said, by example, implement a secure software lifecycle, development lifecycle, okay? What that mean exactly, and how do you validate that your software development really includes security from end to end? And anyway, if we are going in the software lifecycle, the software lifecycle stop at the delivery of the system or the application. So what happened after? So a lot of standards don't cover, as John said, the same element, and not always on the objective. They didn't always define an objective way to validate or verify what you have to implement. Say, one of the control I hate the most in 27001 is the one who said the infrastructure must be secure. and you have one page explaining that. If you give that to an engineer, they may implement what they think it is. So standard have to become more mature on that part, and that's why we need more experts to bring their knowledge to help to clarify all these elements. Otherwise, security will be dependent of the understanding of the developer or engineer that he will read the standards.
I think as well, with some of the standards that we've been working on, and it's our colleagues sometimes. I think Luke referred to it earlier, where we're talking about a system, software, application, but we actually use the word entity. And the entity, when you start looking at our standards that we've been working on, that entity could be a bus, it could be a car, it could be a radio, it could be a house. But then I think some people on some ISO committees, how do I put it? I think it's not that they don't understand it. I think they're almost frightened by the fact that you could almost have a standard for everything, regardless, because we've left the standard with the characteristics that you adopt at the point that you need them. And is that about right, Luke?
Sorry, I was in mute. Absolutely. And anyways, we can go switch on the question number 2, and Joe already start with the 62335, as you told us, or 234.
443, 62443, and that specifically refers to operational technology. So the moving away from the focus just on processing data to also being able to generate actual, they call it an actuator, control something that physically does something, whether it's generate an alert or close or open a valve or that sort of thing. And there's a lot of focus on making parts of our utility infrastructure very secure. And one of those strands, 62443 subsection 3, which then has a whole lot of additional subsections, refers to the software and the software lifecycle being secure. And I had wondered whether your standards were going to delve deeper into that area to make to be able to help people understand whether the software had been fundamentally designed in a secure way, because there are increasing concerns, about flaws and backdoors, etc., in our software. And you kind of referred to that a bit. So I wondered if you were going to say yes, but of course 62443 is quite broad, and we're focusing on the software bit.
Yeah, I think, Joe, that's where SC27 Working Group 4 is probably, and IST 334, which is the British standard, they're effectively the same thing. I think that is one of their main functions, because it isn't, it's labeled as cybersecurity, but it is security and controls. And then that dovetails so much with the software with Working Group 13. There's again overlap, but with different. They almost, they support each other, and hence why both with Luke and I on both, it's quite a good way of passing that information back and forth and inputting that into each other's streams. So yeah.
I come back to you, Joe, and maybe others can answer too. You're talking about you implement 62443. What are your feeling? It was easy to implement. It was clear. Did you have a lot of discussion with your engineer or your developer to see what that means? This specific requirement.
IEC 62443, there are accompanying, I hesitate to use the word certifications, but there's certainly accompanying guidelines and accreditation processes to assure users, to assure people that certain elements comply with the different clauses within 62443. So I'm left with the impression that it's quite mature. There are suppliers out there who will attest to being compliant with 62443, and I'm going to say subsection 3 for secure software and secure software lifecycle. So for certain products, so someone big like Mitsubishi or Siemens, they will say that this offering is certified to 62443, and then you can question that. How are you sure your suppliers? How do you make sure that hasn't been compromised, etc., and so on? So certification is key for use and adoption. I think it's very helpful. Organizations, not everyone in the organization can be expert on every aspect, so they rely on robust programs for assurance and certification that those standards are being complied to. So from that respect, it's very, very helpful standard that there is some certification to challenge suppliers with. Sorry, I ran out of English there at the end to insist that suppliers comply with. Yes.
But yeah, certification come after. I mean, the certification body will certify you once you implement it. My question was upfront. Did you have problem to implement it? Did you implement 62443?
No, I think there's typically with the IEC ISO standards, there's for the sector I'm working in, I like the fact that I think they're generally written for engineers. And engineers like the structure that they come out in. It's easier for the technical engineers to relate to that than it is, say, to CAF guidelines, NIST guidelines, which many of the technical people think are too broad. I think if organizations are realistic and pragmatic, then ISO 62443 is quite reasonable to navigate around. If organizations try and do all of it in one go, try and, as I say, boil the whole ocean, then they're going to lose. They're going to run out of steam. But gradual improvement through using 62443 is relatively achievable for organizations, I think.
So that means, if I understand what you're saying is they have room for interpretation on how you implement it, to implement it best step by step, by the way.
Yes. And the standard itself references improvement, if you see what I mean, along the way. So and it has a lot of wrapper material, perhaps related to what you said about context, assessing your risk and how much of it you need to apply where. So that helps, I think, give organizations a chance.
Did someone else implement or try to implement any standards inside the organization? Your organization? Thank you, Joe. No one? Not even 27001?
Oh.
Well, I just want to ask a general question, and I know we're running out of time, but sort of, if a large organ such as the British Post Office was wanting some suggestions about guidelines about software for their organization, what would you see? Trustworthiness?
I would say choose your management carefully and let them follow the procedures. that, Graham, without dwelling on it, that was one of those systems where people, it's not just about the victims there. The processes were abused, ignored. No one bothered to check. It was undocumented. Yeah. So I see Dinesh wants to come in.
Yes, hello. Yeah, I just had something to sort of talk about standardization again. So what I've looked at is the European standardization system, which applies through all the 34 European countries. And they have these standardization organizations called, there are three of them basically, the European Committee of Standardization, which is CEN. Then they got one called CENELEC, which is the European Committee of Electronic Standardization, and they got the telecommunications ones as well. So I think they have a way of where the standardization is well sort of the process is much more organized, and they have these organization bodies, because I'm actually a part of one of the standardization organizations, which is called the JTC 21, which looks at the AI standardization and looking at what needs to be done with, let's say, the AI life cycle, how it's implemented, and several other things as well. And also there's the IEEE, which does a lot of standardization as well. I've been involved in the IEEE 2933 standardization, which takes care of the basically clinical Internet of Things, devices, and how those can be standardized, and how their security can be looked at. And that's a very well developed standardization, and it's been going on for 2 years. And I've been a part of one part of it, which is basically setting up an AI-based process to train people on healthcare devices, Internet of Things devices. So yeah, I just want to share that with you. Yeah, that's me.
Yeah, I think it's fair to say there are quite a few. The European ones, I think you said 3 of them.
Yeah.
And I know I'm losing track. Last week we were in China. And again, yes, the European standards committees also are represented on ISO. So there is quite a lot of cross-pollination, which is handy. And a lot of the people who are on those committees are sitting on their own countries' committees and on ISO. So, and yes, and the IEEE, I think they're might be part of the JTC group as well, but I might be wrong there. So yeah.
Yeah.
So roughly, I think we are 10 minutes over on the schedule. Graham, I'll let you conclude.
So
we are sorry for that.
That's okay. So thank you very much to John and Luke for their presentation. It shall go up on the Institution of Analysts and Programmers YouTube channel early next week. And thank you for those who attended the meeting. The next webinar will be on Friday, October the 17th at 2 p.m. And the presenter will be Dinesh in this meeting. So look out for information regarding that webinar. So thank you very much. And I'll end the recording. So have a nice weekend, everyone.
Thank you. Thank you, everyone.
Thank you. Bye-bye.
Thank you very much.
Cheers.
And have a nice